Okay, good morning. Happy to be here. So it's my first time at this conference. Going to give a talk today about submarine and terrestrial network developments in the Middle East. So whenever I come back to Dubai, I'm always amazed at all the things that are new here. It's a new street, it's a new mall, it's a new world's tallest building. Always something new here. Can I just use this one? It's up to you. Yeah, I'd rather just use this. Can you hear me okay with this? Is it okay? No. Is it okay here with the microphone? Okay. So yes, everything is new in this region constantly, and it's always changing. But many ways it's changing you can't really see because it's under the ocean or it's under the land. It's buried. So let's look at what's been happening in the region for the past few years. So this first map I'm showing here is a map of the Middle East submarine cables in 2008. So the focus of cables was largely there was three main routes linking Europe to Asia through the Middle East: Flag Europe Asia, CMOE 3, CMOE 4. These are cables that have been around for quite some time, carrying a lot of capacity. Besides those, you had some regional systems such as the Flag Falcon cable and some regional systems within the Gulf, so FOG and Transworld, Qatar, UAE. Then things started to change rapidly. So in the past 5 years, since 2008, there's been a revolution of new submarine cables in the region, both long-haul cables linking Europe, the Middle East to Asia, but also more cables within the Gulf. So let's look at that. So this is a map that's showing the current state of the undersea cables that are in the Middle East. So as you can see, there's quite a few new cables within the Gulf area itself. So just a few of them that have been entered service in the past 2-3 years. There's the Tata Tijian Gulf cable. There's the Gulf Bridge International cable in the Gulf. And going around, there's some cables between Iran and Oman. And the big change has been the large high-capacity cables that are linking Europe to the Middle East and Asia. So you have IMEWE, EIG, which is the Europe-India gateway, and there's a CECOM TG and Eurasia cable. Two cables not shown here that also play a role are cables that go from Egypt to Europe. So the TE North cable and the Hawk cable, also owned by Reliance. So these have really transformed the area. The biggest change is the number of paths going from the Middle East to Europe was just 3 cables. It was just 3. Now there's 8 paths subsea via Egypt. So it's really added a higher degree of resiliency to the connectivity in the region. The most recent developments that we're seeing are not just under the ocean and the seas, but are also across land. And there's an increasing number of terrestrial routes or hybrid routes that use both a subsea and a terrestrial component to connect to the region. So let's look at a few of these. The first one, starting up top, is the EPEG. It's the European Persian Express Gateway. This goes from Germany to Austria, Slovakia, Ukraine, to Azerbaijan, and to Russia, and then down to Iran. It then crosses and goes to Oman. This cable is going to be joined kind of by a sister cable, perhaps you want to call it the Bay of Bengal Gateway cable, which is shown in the gray down here at the bottom. This is going to be ready at the end of the year, hopefully. Perhaps it'll be delayed till the first of next year. This will link Oman and the UAE to India, and going over to Southeast Asia to Malaysia and Singapore. Other terrestrial routes that are new in the region is the Gulf Bridge International cable. They have developed a route linking Kuwait to Turkey via Iraq. That's shown in the blue there. So that's the GBI North right up there. That also entered service just in the past year. Some of the newest additions to the terrestrial game. One is using the GCCIA infrastructure, and it's called MEETS, which is the Middle East Europe Terrestrial System. This is going to be owned by Data MENA and Vodafone Qatar and believe Zane as well, maybe one more carrier. So using the fiber across the GCCIA grid to link the various Gulf states from Kuwait down to the Emirates. There's also the GCCIX system, which is it uses the same pathway as well that has been in service for about 2 or 3 years now. One other new cable or system is this one you can see in green, which is called Gulfstream Amir. Amir, I believe, is Alternative Middle East Europe Route, and it also has a nice meaning in Arabic as well. So this is a system that's going to link the UAE across Saudi Arabia, going through Jordan, and then it's going to work with Paltel and to connect to the Med Nautilus cable system for further access into Turkey as well as into Europe. So this is one of these hybrid routes. So it's using partially a subsea cable in the Med, linking with terrestrial cabling across the Arabian Peninsula. It's worth mentioning some of the two initial planned terrestrial systems that have had some problems. First is the JADI, the Jeddah, Amman, Damascus, Istanbul system, which is it's only partially in service now. So just the span from Jeddah to Jordan is currently in service due to the issues in Syria. The cable has been damaged and is not currently in service because it had been providing service all the way from Jeddah through Amman, Damascus, and up to Istanbul. RCN, shown here in the gray dashed line, was also an attempt to create a terrestrial path from Saudi Arabia to Turkey, also not in service due to the Syrian problems right now. So with all these new cables, what has been the impact in the region? Well, the amount of bandwidth has clearly been soaring. So looking at the amount of international internet capacity linking Middle Eastern countries, it has soared about 72% compounded annually for the past 5 years. Very impressive growth. So going from far less than a terabit to now over 4 terabits just a few years is a very amazing growth, and probably one of the fastest that we've seen of any region in the world. So where does the capacity go? Well, or where's it growing the most? The most growth has been between other Middle Eastern countries. So well over 75% the past few years has been the growth rate of new internet capacity between Middle Eastern countries. But also the growth still very strong to Asia and to Europe as well. But the real key when thinking about how much is the internet capacity growing between the Middle East and the regions is the scale of it, because it's not really that big actually still. So between Middle Eastern countries, it's only about 6% of the capacity is between countries in the region, which is similar to the amount of capacity that's going between the Middle East and Asia. Well, as Europe, I mean, look, it shows here that 85% of the deployed international backbone capacity between the Middle East is going to Europe. And the role of Europe is one that we've seen growing steadily for quite some time for many regions besides the Middle East. So looking at North Africa, Sub-Saharan Africa, South Asia, what this is showing here is the share of internet capacity connected to Europe for that region. So you can see that it's well over 80% for both the Middle East and North Africa. So let's look at technology for a bit of what's been changing there with undersea cables. So we're moving rapidly from a 10 gig world to a 100 gig world. And what this is meaning for undersea cables is that even cables that were built a decade ago, that were built optimized for a 10 gig system, are now capable of handling 100 gig waves. So here's an example of what this means in terms of the capacity per fiber pair. So the Falcon system, which is a ring system here in the Gulf, was built in 2006. Could handle 64 10 gig waves potentially per fiber pair. Then the guys said, we can push it even more. Let's do 96 now. So really getting really high here. in the past few years has been a pretty big shift. So the initial thought was we can do 40 gig waves on the cable, which would be 40 times 40. So a very strong increase there in the cable's a fiber pair's potential capacity. But with the 100 gig potential, it's soaring. So this is a cable system that has been built many years ago, but can now handle 59 100 gig waves per fiber pair. Clearly, it's nowhere near has that much lit right now on it, but it just shows that these older cables are going to stay viable for a long time in the future, and are going to play a very meaningful role in providing the capacity needs for the region. So, we see all these new cables we talked about in the past few years, but it's important to realize still that the role of the old cables is not less, or they aren't being phased out. They're playing a very vital role still in how capacity is being carried throughout the region. Looking at the situation overall of the lit capacity versus the potential capacity on cables linking Europe to the Middle East and Egypt, there's been a transformation as well. So 2008, we mentioned that there was just these three main cables. Capacity was starting to run out on the route. It was very heavily utilized, 77%. But with the addition of these numerous number of new cables, plus the ability for old cables to carry 40, 100 gig waves, we're seeing that capacity soaring as well. So even with this rapid growth of what's been lit, with the share of lit potential capacity has plummeted. It's now just about 10% we think at the end of this year, the end of last year. But one of the ironies of having so many new cables in the region and all this new capacity is that cable damage is still an issue. I think we all recall in 2008 there was multiple cables that were damaged in the region, a lot of problems with the impairment of access. So certainly, adding 5, 6 new cables is going to help, right? It's going to make a big difference, making things more stable. Well, this is a headline from just last year. It's almost the same story. Damaged cables cause internet service disruption in the Middle East. So adding new cables certainly is very important. Does make the situation more stable, but it's not having the effect of totally ending problems with connectivity. So there is still a need then for more new systems. So that's why we're seeing focus on terrestrial networks as well as subsea cables that would bypass Egypt as well. So looking at some of the new cables we see being planned in the region, I mentioned this first one, which is going from the UAE, Oman to India and Southeast Asia. That's the Bay of Bengal Gateway, which will hopefully be ready by the end of this year. And there's 2 more really big cables coming up in the next couple of years. So we have the AAE1, which is Asia, Africa, Europe 1, and the CME5 cable. So these are the traditional consortium cables going from Europe all the way to Asia. They're going to be hitting all of the usual spots in the Middle East as well. These cables are optimized for 100 gig transmission, so I think each cable has the potential to carry between 30 to 40 terabits of capacity. So once these are in service in a few years, you'll have even more options for carrying capacity and helping to provide more routes. For the terrestrial developments that are still upcoming, the MEETS cable that I mentioned, that's using the fiber over the power grid, they're planning to extend that fiber from Kuwait to Turkey via Iraq in the future. So that would then offer a complete terrestrial solution from the Gulf countries through Iraq into Turkey as well. There's talk of more routes that could go via Iran as well, and there's been an interest in creating a Libya to Sudan route, linking the Med and Red Seas. A very challenging idea to implement, but there's companies that are trying to work to make this happen, to provide a way to bypass Egypt. Let's look at prices quickly. So when you have a lot of new capacity, new cables, that often tends to lead to prices getting cheaper, or helps them get cheaper faster. And that's definitely been the case here. So there's always a range of prices available in the market at any one time. And in the prices shown here, it's a Marseille to Fujairah 10 gig wave. It's an IRU price. The range about 4 years ago was $6 to $7 million for an IRU. Currently, it's can be $800,000 to about $2 million for an IRU. The range really depends on the cable system that's being used, not just who is providing the capacity. So certain cables have a lower price with them. Certain cables offer a higher price. So there's not a single price to get between Fujairah and Marseille. It depends on who you're going to use. And both prices are, or all prices are still, they exist. And so volumes are happening at all parts of the market here. So when transport gets cheaper, a common knock-on effect is that we also get cheaper IP transit, and this has definitely been the case, especially in the past year. So what this figure is showing here is the price of a 10 gig E in Dubai Q2 of last year versus the first quarter this year. So you can see that the range there, going from the $20 to $30 per meg per month. Now, from what we've heard from operators, they're saying that it's available for between 10 to 15, 17, around there. So clearly this has been a rapid change of the price of transit that you can have within the region. So finally, just a few concluding thoughts. All of the new construction that we've seen has certainly infused the region with lit capacity, but also the potential. So there's the ability to add a lot of capacity to the current cables beyond what they're currently capable of handling. The market remains fractured in a way that just because you have these large number of cables does not mean that every operator is going to have capacity on every cable. So the diversity offered by the cables is kind of missing. By looking at a map, you see all these cables, think, oh, there's so much capacity, so many cables. But the reality is certain operators will only buy on certain cables. Certain operators want to avoid certain countries. So you really have to look at each network is going to be a unique case of which cables they are using to provide connectivity to Europe. Definitely seeing more local interconnection here. As we all know, the UAIX last year, Data MENA, Smart Hub as well. Definitely playing a role in making more interconnection and content being hosted locally, but there's definitely still a focus in connecting to Europe, as I showed the slide previously, with all the capacity going to Europe, and that's going to continue with the new cables that are being built. There's money being invested to have capacity to Europe. And finally, despite the falling price of transport and IP transit, cross connects and backhaul fees do remain pretty expensive in the region as well. So you can't just look at one single price point as the ultimate judge of is it a cheap or expensive region. All these factors, all these costs add up. So things are getting better and are improving in price. And finally, in case you're not aware of it, we do offer a online submarine cable map, which is free for anybody to go check out. So it's at submarinecablemap.com. It depicts both existing as well as planned cables, and it's updated often. So please feel free to use that in the future. And that's all I have today. I'm happy to have questions if there are any.
Thank you, Alan. It was very informative, at least for me. Questions, please?
Yeah, hi, Marco, RIPE-NTC. Frequent user of your submarine cable map. Are you planning on doing the terrestrial one as well?
That's a very good question. We did launch we have a Middle Eastern map right now. If you go to our website, there's a Middle Eastern map that shows the submarine cables in the Middle East as well as the terrestrial cables as well. So that is available for the Middle East. Trying to show every terrestrial network is challenging for us to have the data, because clearly there's a lot of fiber that's national as well. So I was just showing the international terrestrial networks as well. So, and many countries aren't so happy to disclose where their networks go for obvious reasons across land. So we have some issues there in trying to present that. You know.
Alan Gaurav
Yes.
from Limelight. Do you see the center of interconnectivity for Middle East actually coming to Middle East anytime in future?
So you say the center of Middle East connectivity coming to the Middle East. Well, I think, as so I was showing the most rapid growth of internet bandwidth in the Middle East is between other countries in the Middle East. So it's definitely growing, but it's going to take quite some time before you see that much capacity between countries, growing at a much faster rate to exceed what the capacity is going to Europe. I mean, within Asia, you see much heavier concentration of between Singapore, Hong Kong, and Tokyo is very high capacity compared to the Pacific and going the other direction as well. I think we're many years away from seeing that type of an environment in the Middle East where you're seeing as rich of intra-Middle East capacity as you do in other parts of the world. But it's definitely going in the right direction at least. And I think one issue there is, Dubai is basically the hub for the region for the internet, right? And there's other areas that are trying to become hubs, Oman or Qatar, or whoever else is trying to do this, but there isn't the same level of scale yet among these different places as there is within Asia or within Europe, where each place has in itself large scale already.
Any more questions? I have a question for some of the gentlemen here, if they want to answer it. Still, as you mentioned, that international connectivity or international IP transit is dropping significantly in the past few years, but still within the countries, still the prices of last mile is quite expensive, and even internet capacities or IP connectivity down to the enterprise is still expensive. Can anyone comment why is that still going on? Maybe some of the telecoms, or nobody wants to do that. That's something at least we're seeing in Saudi Arabia. It's not dropping as much as you are mentioning here, but that's something also for us all to look at in the future. Any other questions?
Thank you for the presentation. Do you have any statistics on the utilization of those links?
Pardon me?
Utilization? You're talking mainly about capacity, available capacity, but what about the utilizations?
In terms of the submarine cables, how much the lit is actually being used by operators?
Not the lit, but the fiber that is lit, how much of the capacity of that link is utilized? Are the user getting really good quality of service, or these links are fully utilized when you talk about traffic?
Yeah, I mean, it's going to vary a lot by the cable system as well, and depending on the uptake of the operator. I can't share that on a per cable basis really, though.
Is that information available?
It depends on the operator.
Hani Abul Khair, QualityNet Kuwait. As you can see from the submarine cables connecting our area to Europe, we can see a lot of single point of failures, especially in Alexandria. And this is in history. We had a lot of cable cuts affecting the traffic from Middle East and Far East. Do you know if there is any plan to make ring to avoid this bottleneck? Any cable providers trying to avoid this bottleneck or single point failure in Alexandria by making, for example, through Africa to?
Absolutely, yeah. So one of the things that I mentioned was there is a let's look here at that. So there is a plan being discussed for a Libya to Sudan terrestrial path that's been discussed for many years that would provide what you're saying exactly. The other issue is, let's go back here looking at the so there are these various terrestrial paths that exist that are providing options that would avoid Egypt. So there's the EPEG cable, there's the GBI North system, Gulfstream Amir. So there are an increasing number of terrestrial options that do help to bypass this. Now the challenge is, how stable are these routes? Cables get damaged on land as well. The other issues are there's some political issues. Certain countries are being crossed that certain countries maybe don't like too much, and they will not use the cable because it's going across a certain country. So there's definitely been a lot of different routes that have been built to try to avoid the Egypt issue, and it's one that I think is definitely an important one, as we were seeing damage on cables there happening all the time. But it's important to note, even with what's happening in Egypt and this focus of cables there, the two biggest cables that have been announced in the past 2 years, the AAE1 cable and CMOE5, they're both going the same way. They're using the same path as other cables. So you're adding more cables across the same path. So it's not really you're adding two big cables on the same path. So it's not really adding diversity. Those two at least. So I think you're going to still see cables going to Egypt. It is a major transit point, and it will still be that way. But there's lots of options that currently exist, and there's more being planned.
Okay. Any more questions?
Yes, I would like to know how. Yes, my name is Joseph Jabakanji. I'm from TCL, Tata Communications. I would like to know if you have any statistic about all the capacity, as percentage-wise, how much carries IP and how much is non-IP, like MPLS and other things.
Sure, I don't have that on hand to share with you, but I would assume it's rather high.
But
It's
you
a good
think it's
question.
rather high? The IP is high.
Sure.
Any more questions? Okay. Thank you, Ellen. Thank you. Our next presenter is Mr. Jim Cowie from Renesas. He's going to talk about mapping the Middle East's financial industry.
Thanks. Sure, probably full screen it.
You want the mic?
Well, I'll probably use this one. Let's see. There we go. No, I'm okay. I'll just.
You like to walk
A little bit, yeah, but I always have bad luck with these mics, these little mics. But. Sorry? There's no F key here.
There was F1.
Oh, yeah, here we go. Ah, technology. Thank you. You'd think I'd figure this out after all these years. Cool. I'll start here and then we'll see what happens. All right. Thank you for the invitation to speak on this. A lot of you know probably Renesas has done historically a pretty good job talking about the relationships among carriers and service providers. And recently we've been moving up the stack a little bit into more enterprise operations. So we're doing a little bit more along the lines of network performance management tools for the internet. And one of the industries that is interested in that, of course, is finance. And so I was tasked with actually going out and making a map, and said the challenge was pretty simple. Let's see if we can find the entire world financial industry and figure out how they use the internet. Seemed pretty straightforward when we came up with it in a meeting. Then we had to go dig them all out. So today I'm going to give a little bit of a background. This is the first in a sequence of talks, hopefully, that will talk about the regional footprint of the financial industry, whatever that means, and figuring out how they use the internet and whether that's different than the way that everybody else, all the rest of us, use the internet. So the world's financial industry obviously has a lot of money because they're the financial industry. They buy hundreds of billions of dollars in telecom services every year. They are moving towards the cloud, especially in places where standing up their own presence in local data centers is expensive. or impossible. They have moved rather agilely towards using cloud services in Europe and North America, even though now, of course, there are reasons to consider building cloud elsewhere. And the internet is playing a larger and larger role each year for these folks in figuring out how they connect their services to their customers, how they get from their cloud presence to the consumer. And what's interesting to me is that it used to be the case that the financial industry folks would buy private lines and wire things up as they needed to be. And when they needed to buy internet services, they would just go find the best provider and buy from them. And they didn't really get into the active management of routing or their internet presence. And increasingly, they are becoming a more active group. They're becoming sort of first-class citizens on the internet. They get autonomous systems. They get provider-independent space. And they're starting to think about what their responsibilities are in terms of participating in the policy discussions, internet governance, and hopefully more and more coming to meetings like this where they can talk with the operators about the technical internet. So today, in the time we have, I'm just going to go over more or less the initial version of this project, which the goal, as I said, was to identify all of the IP address space that financial institutions use, to set aside the slice of that global space of spaces that belongs to the Middle East. It's always hard to say what the Middle East is. It's different every time we come here. But today this is going up as far as Turkey, not including a lot of the Maghreb, but basically the countries that you see here. We wanted to summarize how the financial industry is buying internet services right now, how they connect to each other, how they connect to global markets. And then hopefully we can figure out something about how the Middle Eastern financial sector is different from everybody else, if in fact it is. So very briefly, the way that we built the model is interesting. It is just a model, and it's not a perfect model. This is maybe a Gen 1 of a more perfect model. We basically went through all the registries looking for people who had financial keywords in their organization strings, like bank. Bank is a good word because it's cognate across so many languages. We also looked up everybody who had a SWIFT code. So SWIFT is the online system for doing payment transfer. And by and large, these are all people who need to move a lot of money very frequently. That's a pretty good substitute for the financial industry. We did rule out a few oddballs like Huawei, other vendors who actually have SWIFT codes for some reason. But by the time we got done, we had about 28,000 IP blocks, and we had about 2,800 autonomous systems. So once we folded in all of the originated network space for those ASs, we got our way up to about 66,000 IP blocks. And as you'd expect, because this integrates over all of history since the beginning of the internet, as long as those are still registered, a very large chunk of these are in the US, about a third. But there were about 3.5%, a couple of thousand, that are here in the Middle East. So we'll show a bigger map in a second, but here's how these sort of break down across the Middle East. And it is important to remember that this is where they are registered, not necessarily where the owners are or where they're used, but it's a proxy. So a very strong presence in Saudi Arabia and Qatar, Turkey and UAE, and on down from there. Here's the bigger map. And for context, you can see that China, for example, has a few thousand. Russia has about 4,000 that we were able to find. This is obviously a sampling from a larger population. But the numbers are, by and large, about what you'd sort of intuitively expect, given the size of the local economy. With some exceptions, there are some places that are very finance-dense, as you might imagine, like Cyprus, which has 147. If you take a look at what these addresses actually are, right, these are just IP blocks. I didn't say how big they were. What's interesting is that if you look at the classless boundaries of these nets, you see a distribution with two peaks. So the first peak is right here at /24. My laser working? Not really. So /24, that's kind of the smallest block that's going to be globally routed. So you can think of those as the guys who do it themselves. These are routable blocks. There's a second, much larger peak at 29. So clearly the /29 is although not routable, is being routed by somebody else as part of a much larger block. And that, in fact, is a more prevalent model for the financial guys. If we take a look at all of those providers and do the simplest thing in the routing table, which is just to say who originates the traffic, you can see that ITC, with the big fiber network in Saudi Arabia, is the top provider for financials in the Middle East, followed by Etisalat, NetVision, Turkey's Super Online, Orbit Satnet, which I thought was interesting. So there's a lot of financial providers still buying satellite services. And on down the net, there's obviously a very long tail of 144 other providers contributing a full third. So here's where we start to break it into the first attempt at building a model. The different categories of the role of the incumbent in providing connectivity to the financial industry. And in the Middle East, the incumbent's role in the market is everything in terms of robustness and resilience and pricing. So there are some markets where the incumbent is pretty clearly still providing most of the service to most of the financials. There are some markets where there are secondary connections to the international markets that don't go through the incumbent. There are still more markets where the incumbent has 2 or 3 real obvious competitors to serve the financial industry. And then I'll show you an interesting one towards the end where the incumbent is mysteriously missing from providing services to the financial industry. Let me go through some maps, and these are always hard to see from the back row or even the front row, but these slides will be available online shortly. Here's the Iranian banking industry. Snapshot of the ASs. So down the left-hand side, for example, we've presented 12 different AS banks with their own autonomous systems. And they're buying service from about 9 internal providers, sort of second layer providers. And then almost all of those are going up through TIC, the incumbent, who controls the traffic at the border. And they have the circle around them there. So you can see their very central role. Once you get past that point, then I think as Alan's talk suggested, there are different physical paths that are available to them, including the EPEG terrestrial route, which either goes south to Oman and then off through Bharti Airtel, or it goes north through Azerbaijan and Russia, and then you get cable and wireless. But either way, TIC is very firmly in control of the banking industry and their connectivity. And there's some implications for that. It's not just a theoretical concept that that's suboptimal. There was an event earlier in March where TIC lost its southern route. There was an interruption. They lost the connectivity through Omantel, through Bharti. And so these are actual results of trace routes that we performed to the financial industry IPs in Iran. And you can see that latencies here increased by 150 milliseconds because only the paths through Telia remain, which are the northern route through Azerbaijan. And in fact, during the same event, as measured, Iranian banks lost 3/4 of their upstream diversity. So most of the paths they used are gone. You can see that the scatter plot of latency measurements tick up rather significantly for this window of a few hours. In Saudi Arabia, it's interesting. There's a lot of people going through STC. You can see, of course, ITC has a lot of connectivity here from these banks. But ultimately, a lot of it comes up through Saudi Telecom. But of course, you can also see some direct connectivity to level 3 and to Cogent. So it's not all one story being told here. There is more diversity. If we take a look at Turkey, it's interesting because you can see different results city by city. So here's Ankara, which is, I guess, the more conservative end of the Turkish market. So banks that are in Ankara are dual-homed. Most of the classic pattern here, you can see 2 that are circled, Turk Telecom here, and Telcom, which is super online here. And you can see that most of these banks are actually are dual homed. They literally have one connection up and one connection down. And so that gives them some diversity, some measure of diversity in terms of relying on a single provider. And Telcom is bringing to the table different routes. They're going through Bulgarian Transit or Tata Transit. If we go and look at Turkey in Istanbul, you see it get even better. So here there's three-way competition now that it's emerged. Not only Telkom Super Online and Turk Telekom, but now Vodafone, Vodafone's Turkish operations, Vodafone now having purchased cable and wireless. And you can see that as we line up the banks here that have their own autonomous systems in Turkey, they pick two. You have three, pick two. Some of them, I think, pick three, which is a really nice fan out. And you can see them all using different routes to get to international markets. Here in the UAE, obviously, this is a major, major financial hub. There are hundreds, literally hundreds of financial institutions that have IP blocks reserved to themselves. And I've listed some of them here. It's too tiny to read, but everybody's here. This is a financial center. So how many autonomous systems do you think they have? How many of these guys went ahead and registered an AS number and started doing routing? 2? About 1. So here's the Dubai financial market, which is the only AS I could find here of a financial. Everybody else has an IP prefix and they use somebody else to do their routing. And so that makes them single-homed by default. It makes them unable to multi-home their traffic to different providers. 86% of them just decided to use Etisalat. About 13% went through Du. And that leaves you less than 1% of anything else. That's basically the story here. Just a different way to do things, a different structure to the market. I said I was going to mention a very strange situation. Here's where I remind you that I always show up at these meetings and present some interesting observations and data, but usually I don't understand the story. So if anybody understands the story here, please complete it for me. Here are the 4 Egyptian banks that have their own AS number, and there are 4, Central Bank, Piraeus Bank, Egyptian banks, and Qatar National Bank Al-Ahli. They buy from Vodafone Egypt, they buy from Etisalat Misr, they buy from Mobanil, all of whom have their own direct international transit, which is all great. And Telecom Egypt is completely missing. And Egypt doesn't have very many registered IP blocks for financial services providers, which in and of itself I don't understand completely. There are only a few. I was only able to find 2 tiny blocks, one /28 and a more specific /30, that are some little branch office of Deutsche Bank in Cairo that actually have transit originated by Telecom Egypt. Everybody else goes with a competitor. It is truly unique within the region. I can't think of another example that we found in the region where the incumbent is missing in action and supporting the financial industry. So all well and good. Up to this point, we're simply talking about structure, and we're guessing that more diversity is important. We don't really know what the outcomes might be. So here's one that we could pick out very easily from our data set. Let's take a look at all of the IPv4 prefixes in a country and count the average number, the average percentage of those prefixes that have BGP instability on a randomly chosen day. Okay, so this will be a percentage. It's true across all countries, it's true across all industries. You want this percentage to be as low as you can. Ideally, the percentage of IP prefixes in your country that change their routes every day to the point of being noticed for instability would be 0. It would always be stable. Let's find out, first of all, what the differences are by region, by country, and then let's find out whether banks do better, or perhaps they do worse, based on the transit choices that they make. So first of all, just at a gross continent level, here's the Middle Eastern region in purple, which is about 3 times the BGP instability of Asia overall. So automatically, the 3 lines at the bottom are Asia, red, green is Europe. blue is North America, they all tend on a daily basis to settle out at about 3 to 5%. About 3 to 5% of the routes in each of these regions will be unstable, will change on a given day. In the Middle East, it tends to be higher, somewhere between 10 and about 17, 18%. And it has been climbing in 2013 for reasons I don't completely understand. But let's take a look at this. This slide, I'm apologizing, is full of numbers, but if we dig in a little bit, let's start right here. Okay, so the Middle East overall, from 2012 to 2013, became a little more unstable. So 13% became 14%. Not really meaningful, but take a look down the list of countries. Here we've ordered them from the most unstable, Iran, to the most stable, which are Turkey and Israel. And you can see that there is a real difference in outcomes across national economies in terms of how things are structured. So it's unusual to me that more than a third of the networks in Iran on a given day have significant BGP route change, but it's true. And in fact, it's gotten a little bit worse over time. Similar statistics in Iraq, similar statistics in Yemen, although, of course, the numbers are much smaller. And on down the list. What's interesting here is that the most unstable countries got more unstable in 2013. The most stable countries, by and large, got more stable in 2013. Now let's move over to the right side and just take a look at the banks. These are the same financial prefixes that I called out before. And by and large, you will see that in the region as a whole, only 10% are unstable versus 14% of the whole country or the whole region. And so that's more stable. If you go down the list of all the countries, you see that in general, whatever banks are doing, however they're picking their transit and writing their contracts, their BGP routing is significantly more stable than the country where they do business, which you would hope to be the case. You think that banks probably do a good job, they probably spend reasonable money, they probably pick high-quality providers and all of that. What's really interesting is that once you get down into the UAE, for example, the banks are significantly more stable than the general population of routes. They have only about half the likelihood of being BGP unstable on a given day relative to everybody else in the country. And you can see that the numbers that they achieve in 2013 across Bahrain, Qatar, UAE, Turkey, and Israel are very similar to what you would expect to see for a financial institution in, say, the United States. Okay.
So just a question.
Yes.
How is that even possible if none of them are doable?
Well, it's possible to still be stable, right? In some sense, there is a certain level of BGP route instability that you get from being multi-homed because you're doing the right thing. You're changing service from one provider to another. If you are single-homed, it makes it harder for you to see any route change at all. So any route change that you see will be route changes that are on behalf of your single provider. So we can hypothesize that in the UAE, for example, these routes may be very firmly nailed up. They are not going to change route very, very often. There may not be a lot of alternative upstream choices that can get factored in beyond the do and Etisalat choice. Does that make sense? So actually, that's all I'm going to say today because I really want to save some time to hear the questions and hear the rest of the model come back at me. But in summary, these are really interesting people. This is an interesting industry in terms of being customers for all of you and, frankly, for all of us. They do tend to be late movers, but once they get going, they have the resources to make some interesting choices. It has been true that financial service providers in the Middle East are being more late adopters than not in terms of lagging, getting their own autonomous system, getting their own address space, setting up multi-homing. And so there are some risks here that I think enterprises and financial folks in particular don't completely appreciate yet, that there are risks associated with not participating in routing having your own AS and becoming multi-homed. And you can measure that in terms of the outcomes, that they are less stable here than in Europe or East Asia or the Americas. But I will conclude it there and take your questions and observations.
Thank you, Jim. Questions? No one from the banks?
Hey, financials here. We have to work on inviting them to these events. I'll have to get to lunch.
Hello. Haitham from Egypt, Telecom Regulatory Authority. I would like to comment on the Egyptian situation you have mentioned. Actually, there are two types of connection for banks in Egypt: VPN to connect branches, and another connection for internet. Telecom Egypt is participating in VPN, especially for large banks like National Bank of Egypt. More than 400 branches. It's connected VPN through TE data. And for international or internet connectivity, there are auctions, many auctions for each bank, and beauty contest actually. So it depends on commercial prices for internet connectivity. So that's the reason of no showing for Telecom Egypt. And as far as I know, each bank has two connectivity for internet, one main connection and another backup. Some of these banks have another backup from Telecom Egypt.
Got it. Okay. So it may not be visible in internet routing, but it's connectivity of a sort.
Sorry?
So it may not be visible in internet routing, but it is private connectivity, or it's a VPN to some place.
VPN, yeah. VPN for 400 branches all over the country through Telecom Egypt.
Interesting. Thank you.
Okay.
Martin Levy from Cloudflare. So let's try a different question here. When you compare financial institutions to more classic users of the internet companies, specific companies, do you see, let's say from your day job at Renesas, do you see banking institutions come to you for monitoring services at the same rate that you see web presence companies or more classic companies? Can you compare them in that measure? And then the second part is, keep in mind that I'm pretty certain that banks have been a fairly high user of services like content delivery networks, maybe more so than other institutions or other verticals to date. And I wonder if you want to comment a little bit about that.
Okay. So to the first point, banks do come to us for performance analysis and for monitoring. And it's in large part, I think perhaps it's a security question almost as much as it is a performance question. They tend to want to understand not only the performance to their customers and their services, but everybody else in the industry as well, which is one reason why we started making more of a broad model on the theory that any performance problem or threat that impacts the financial industry, whoever it hits first, everybody else in the industry assumes that they're next. And so I think compared to the broader content, sort of the classical internet company internet, that in itself has been changing. A lot of the companies that are not at Amazon and Google scale, who are doing classical content internet style companies, in recent years have moved into sort of much more simplified cloud footprint sort of strategies. A blog I wrote recently about the hosting of WhatsApp would be a great example, where they just, they're a startup, they needed to prove their technology in the market, and they went out and bought soft layer services in grew to scale and had no problems. And I think that banks who look at that, the worry is that financial institutions may draw the same lesson and think that there are that the cost savings of doing something like that instead of doing a more globally distributed, close to consumers kind of real internet model as you and I would think of it, is a bit of a risk. So we're trying to put all the data out there so that everybody sees that whether you're doing classic content or finance or whatever, there are some commonalities how you should be buying transit. And I may have missed your final question. Oh. Yeah, I don't have a picture on that. People will use CDNs if they have a big a web front that they need to put up, but not for back office services or anything like that, obviously.
Hi, it's Marco, RIPE NCC. On the instability, do you see a difference between the people that have their own ASN and the people that outsource and have their ASN prefix announced by a telco?
I don't have that data at my fingertips, but remind me to look and we'll look after.
Man Psesos on Technologies. You talked about the BGP instability. Can you please define where is the instability? Is it part of the last mile or within the international links? And most of these countries that you mentioned over there, what's the reason, or if you have any statistics of the reason where any political or financial or economy-based issues?
Okay. It's difficult because when we're talking about BGP route instability, we're literally talking about all of the transit-connected components of each BGP AS path as we measure it from hundreds and hundreds of different BGP peers. So the instability can be anywhere along that path. Typically, it is going to be the last couple of hops or the last couple of ASs. It'll either be origin level instability where they're withdrawing prefixes because they have a local problem, or it's choosing among their providers. That's probably the bulk of it. I don't have good statistics on that.
Hi, it's Andy Davidson from Allegro. I've got a really quick comment and a question, an unfair question, so I'm sorry in advance. But the comment, I think, builds on something Martin just said. If the market for internet service providers is not rich enough, then a financial institution has no option but to go and spend their money in a different economy. And that may explain why in some places the financial institutions are building ASs and reliable networks, and in some economies they're not doing that, probably because the kit and the infrastructure is all hosted somewhere else where they can buy diverse connectivity. And the unfair question is, and it's unfair because I know the way that you assemble the data makes this question possibly hard to answer, but you're really clever and you might have the answer. If financial institutions have got really good internet and really stable internet, who are the people, or which is the sector with the really, really rubbish internet that we should be focusing on winning customers in?
I don't think you really want to sell to people who do rubbish internet, right? You want to sell to people whose perception of the quality of their own internet is that it's rubbish. And I've never met a financial institution that thought that its internet quality was great. And they have the resources to fix it. So, and I'm sorry, I'm operating on like 2 hours of sleep, so I already forgot your first question because my buffer is about 512 bytes today.
It was more of a comment. If a choice of provider doesn't exist, then the content and the services are probably somewhere else.
Yes, no, that's certainly true. We have not attempted to think about what happens, but clearly I think if you're talking to policy people about internet and you want to convince them that good internet and good internet policy is important, you need to talk about direct foreign investment and where people are going to make the choices to cite things because they can cite them anywhere. Access networks can't move, but content can move anywhere it wants to. There's a reason why one of the countries on this map had no prefixes at all. And you have to wonder why its own central bank is operating out of some IP space in Jacksonville, Florida. It's easier in some places and it's harder in other places.
Any more questions? Okay, thank you, Jim.
Okay, thank you.
Give you a break for your toilet. Our next presenter is Mr. Gorab Badaya. He's going to be talking about internet measurement tools and their usefulness.
Almost good afternoon, so good afternoon, everyone. Today, so I'm going to talk about a few of the tools that I actually use when, working in my day-to-day job and things like that. And I put this presentation together last year at another NOG when people asked me, so how do you know these things? How do you get to know these things? Where is the sources of information that you seem to know about? So some of you probably have seen this before already, so you can go for lunch. The others can stay. So what do I mean by internet measurements? Any given day, and as you heard from two of the previous speakers, they all talked about their own measurements or different things. There is lots and lots of measurements that go on the internet any given time. A lot of these are reachability and latency. People measure how far something is, if something is reachable or not. Can you ping something? Can you load something? Things like that. Then there is a lot of routing table measurements. Like you just heard from Jim. There's another guy called Jeff Houston who spends a lot of time collecting routing table information. A bunch of other people do the same thing. Then the routing stability measurements. IPv6, DNSSEC, anything that is the buzzword is getting measured somewhere at some point. And these measurements serve many different purposes. They are not done for one single purpose. And we'll look at some of them, the most common ones, most ongoing ones, and see how, as network operators, we can utilize them. When I started doing this presentation, I thought I'd better classify all of it because, as I said, there's so many measurements going on in the internet. If I start talking about all of them, it'll probably take multiple days to just go through them. But if you want to summarize, there is, I summarized into 3 different areas. There's academic studies. People who are doing regular measurements for academic purposes at academic institutions, and CAIDA, C-A-I-D-A, Cooperative Association for Internet Data Analysis, I think, located at University of California in San Diego, is probably the leading research institution on the academic side of things. Then there is Planet Lab, which provides an infrastructure for people to do measurements. And there are a lot of others out there. So a lot of academic measurements are one-off. Somebody is doing a PhD or writing a master's degree or something, and they go around, do a measurement for 2 to 3 months, publish the report, and then, it's get out there and it's done for it, And those are not really useful on a day-to-day network operations basis. It's like there, it's useful to have in the background, but not really useful if you are trying to use it in your network troubleshooting. Whereas CAIDA publishes data on an ongoing basis that is really useful for network operators. Then we have what I call community or industry run, and in which there are things that are done by RIPE, increasingly done also by APNIC. There's route views, there's a bunch of other looking glasses, and there's the Hurricane Electric BGP toolkit and things like that. And then there are commercially run measurements, Renesas, Arbor, and so on. So today I'm going to talk about, mostly CADA and a bunch of other things that are useful for people here. So how many of you have seen these diagrams? I was expecting more. Yeah, I think quite a few of you have. How many of you actually can come here and explain to me what this is all about? Yeah, a bit fewer. So, this, I put this in here so that you get excited about the whole presentation. Because we've all seen this at different times and wondered, so what the heck is this? So this is a summary or a big picture of, like, CADA collects a lot of data. CADA, is doing measurements on an ongoing basis in a lot of different ways. And this is one of the things that they publish. And around 6-7 years ago, they actually had a paper version of it that went around quite a bit. And, we all saw it. So if you look at this presentation, if you look at this diagram here, this side here is for V4, and this side here is for the V6 one. I hope you see the cursor there. It shows the interconnect density between different networks. So on this one here, let me go to the V4 one. This portion here represents Asia. Further out, this represents Australia. This represents here Europe in the core, and then out there Africa, and this is North America. So you can see that within the region, if you look at the density here, you can see that there is a huge amount of interconnect between Europe and North America. See that it's much more darker. And then there is quite a bit of interconnectivity between North America and Asia, but Asia and Europe, not as much. Right? So that's that way. And then look at this, and then there's a lot of, the dots here actually represent different cities. And if you go to a big version of this and look at it, you can see that in Asia, Tokyo, Hong Kong, and Singapore automatically stand out because they connect to a lot of other places, right? Which means that it is pretty obvious it's a hub. If you go further down, then you'll see Seoul and, sometimes Sydney, sometimes Mumbai come up as more connected places, right? Which lets me look at this map and say, hey, if I'm going to build into Asia, these three are the first thing I need to look at, and then start going at other places, right? For Europe, the usual suspect, London, Amsterdam, Frankfurt, pop up really fast. And then you go further deep, and then you realize that places like Marseille pop up, right? Because that's where a lot of interconnect is happening now, right? That's where the connectivity is looked at. And then in the US, you also see the usual, Aspen and New York, Miami for South America, and then, LA and San Jose for connectivity towards Asia. So leave that aside and look at the V6 one. So you can easily see the difference, how dense the V4 interconnect is versus how much less denser the V6 interconnect is. Right? I think it might have changed in the last 1 year. This particular snapshot is from almost a year ago. But you can see the difference quite easily and how they are connected. So gives you an idea of it. Now, where do they get this data, right? CADA, stands for Cooperative Association for Internet Data Analysis. It's in the University of California, San Diego. CADA is increasingly using this thing called ARC, A-R-K, the Archipelago Measurement Infrastructure. CADA used to give you boxes to put, like proper big servers, but I think at some point they ran into issues with, not being able to scale it as much as they would like to. What they do is they measure path and latency to V4 and V6 addresses visible on the global routing table. So what they do is they look at the global routing table, 400 and whatever thousand these days, look at every /24 that is visible in there on the table, or basically take all the /24s that are announced on the internet and sends a ping and trace route to that IP address for one per /24. And that's the main thing. And they do this from probes in many different parts of the world. And a lot of you probably know about the AS rank stuff. So this is the main source of CADA data, and they create such a rich volume of data that it is used for large number of analysis and presentation and things like that. One of the things that they do is the AS rank stuff as well. So, I host a CADA ARC in Singapore, and this is what I can look I can look at the report on the website and see. And again, I'm trying to show the difference between what it looks like for V4 and V6 from the same node. And, and then there's another interesting thing I'd like to point out. Anyone have an idea what I'm trying to show here? I mean, so this is the V4 diagram here. And you can see from Singapore, you can, most of the world I can connect to except for maybe the Central African Republic and something there. Whereas V6, a lot of Africa is not completely reachable, right? Which might be for various reasons, but that's what the probe in Singapore is saying is difficult for them to get there. Whereas they do have good connectivity to the, quite the rest of the world. But something I realize, or something you can look at this and see this graph over here for V4 versus this one here for V6, and it looks fairly similar. But look at it. The x-axis here is distance, and the y is RTT, latency. Now, if you go through the laws of physics, as the distance increases, your latency should go up, right? Anyone disagree with that? Right? No, so that's good. But if you look at the graph here, you saw that as the distance goes up, you actually see the latency going up, which is fine, and then it actually comes down. Right? How do you explain this? So, I'll explain it. Marco knows that. So, my assumption on this is my probe is in Singapore, and connecting from that part of the world to large parts of Europe actually goes through the US. Because of historical reasons, as Alan said earlier, there's still not enough capacity that comes from Singapore towards Middle East. Basically, India eats up all the bandwidth, so it's still pretty expensive. So anything that gets built from Singapore coming west is built to India, because that's where the traffic sink is. So a lot of carriers in Asia, they tend to connect towards the US. So a lot of paths actually goes to the US and down to South America, to the US, to Russia, and a lot of these things. So that's why this goes up as distance goes up. But at some point, even the distance is further out, the latency is lower because this guy is looking, going through the shorter path on this side. Right? Make sense? So that is an explanation. You can go and look at it further, but at the same time, look at the V6 one. Again, pretty easy to see from your own network where the problems are when it comes to V4 and V6. I had another probe, and this is the host, the blue one, and it actually shows me path to a large portions of the internet. Whom I'm connected to, whom my upstream is connected to, who they are connected to, and all of that. So by hosting some of these things, I get a good view without having to build a lot of infrastructure to do this kind of thing. And that's what is pretty useful with this CADA ARC project, is gives me pretty much an ongoing report into my own network. Right? You can host this and then see, okay, don't have to build all of these tools yourself. This is what a CADA ARC looks like. When I first hosted one of this, it was to be a big 1U box, and used to have a lot of problems with customs and all of those kind of things. Now they do it on a Raspberry Pi, and you can just plug it into your network and it just works. And that's where they have it. And so CADA ARC is basically pinging and tracing out between their own nodes. So from point A to point B between their own network. They're not doing it to some standard thing. So the more they have, the better it is. And because it's academic, they are in most universities, mostly at universities in a lot of places. But increasingly they are putting, letting people host it in commercial networks as well. So that was the CADA arc. The other tools that I really use are all RIPE stuff. And I'm going to skip through this because there is a presentation tomorrow by Kristen, and there is a tutorial on Tuesday about how to use a lot of these tools. There is the RIS, Routing Information Service, which gives you a pretty good stuff. There is DNSMon. There's TTM. I think it's no longer called TTM, but and then there's the RIPE Atlas. In fact, RIPE Atlas is really good. And if you don't have one, you don't know about it, you should definitely talk to the RIPE NCC staff outside. I think they have probes to give out here as well, right? Anyone from NCC wants to stand up and wave their hands? Yep. So, talk to these guys. And, I'm going to skip through all of this. But one thing that I point out is a lot of people think you can put a RIPE Atlas in your network and that benefits other people. And that's not always true. Because once you host a RIPE Atlas, you start getting points. And you can use those points to create your own measurements. And that is the usefulness of hosting one of those things in your own network in your house or something. Right? I hosted once from the very, very beginning, and I think I have 1 million points or something. So I can give points out if people really want it. I need to go faster. Then there is APNIC stuff. Jeff Houston, I don't know how many of you have heard of him, but he does a lot of research work, a lot of measurements. And that has generally been, now we're trying to put it under APNIC research. What they do is they do measurements. Currently is a big measurement focus on IPv6 using Google Ads. There is ongoing measurements on 1.2.3/24 and 1.1.1.0/24 because APNIC got assigned those address space. CIDR report, BGP updates, like we talked about earlier, and as things pop up. We had this big scare about NTP, which Philip is going to talk about after the last tea break, and things like that, DNSSEC. So, none of that. I'm just going to focus on the V6 one because we heard Dr. Ibrahim talk about it in the morning, so I updated this slide. So you can go and see here what his research says, which areas are well covered, which are not. I'm not going to drill into this because I'm running out of time, but you can go there and look at it, labs.apnic.net. You can go and get details like this, like IPv6 measurements by AS number. And basically what Jeff is doing is he's creating a Google ad which is available only on V6 and both on V4 and V6, and saying how many people access it over V6 versus how many people access it over V4. Right? And he'll tell you a long story about it, but it doesn't cost him any money, so it's a pretty good way of using Google to do it. But that is the way. And you see, still, there's quite a bit of academic stuff at the top. Of course, there's Facebook at the really top, but all the, beneath that, until Google, is all academic networks. And go drill to that. I picked up the data for Saudi Arabia this morning during Dr. Ibrahim's presentation, and this one actually shows which networks are capable of V6 and which networks are capable of preferring V6 for all the communications. Right? So it is one thing to have capability, the other thing to actually prefer it, use it in their network. So either the DNS is not done properly, so they're not getting quad A records, or something. They've just done BGP, announce the routes, and say we're V6 capable. That's not enough. Right? So this shows a really good differentiation there. And over the years. Jeff also does CIDR report. It was initially done by Tony Bates, then fixed, kind of updated by Philip, and done by Jeff. And as I say, if you don't get at least 4 or 5 copies of it, you are not on all the, the right mailing list that does internet operations. It is sent to the MENOG mailing list as well. It is a weekly report on the BGP routing table and DA aggregation. A few years back, Jeff also started the BGP update report that actually lists the network that are pretty unstable. Like what Jim was referring to earlier, there's a weekly report that comes out which basically lists, hey, this ASN and this prefix are really, really unstable as viewed from X, Y, and Z. Right? And sometimes that is really useful to be on those because you might see your own prefix there. I've been in a case where, oh, I'm never going to have this problem, but realized that one of my prefix was flapping way too bad because the router was running out of memory and it was withdrawing, announcing, withdrawing, announcing. And as you know, so it's good to see if your network pops up in there or one of your other networks. That website over there, CIDR report, is something you should bookmark. Look at it on a regular basis because it gives you a whole lot of information. I looked it up for 8966 Etisalat this morning, and it'll show you who their upstreams are and who their downstreams are, as seen on the global routing table. Pretty easy to see. Then there is route views and BGPlay. Route views is available at routeviews.org. A long time ago, it was started so that, you know, when you do BGP, you announce something to someone, you have actually no idea of what they're actually receiving. You have to email them and say, hey, can you send me what you are receiving from me? You know, so route views solves that problem because when you announce to route views, you can go to the route views router and see what you are announcing to them and what other people are announcing. You know, what is the global routing table looks like, and you can do trace route and things like that. Route views collector peers with a large number of carriers, and they do eBGP multi-hop. Their main nodes are in the US. So you don't have to be connected directly to them. It can be done remotely, right? And you can give them a view of your network so that other people can know about it. And then there's the cool thing called BGPlay, which uses route views and RIS data to actually do a very good animation. This is pretty old because I picked it up from their website. You need Java to run this thing, and I can't seem to make it work on my laptop these days. So, but it will show you how things have changed over time, right? So if there is a fiber cut somewhere near Alexandria, and you'll see all these routes converge back towards Asia and towards the US. Suddenly you are losing networks behind, you know, Reliance or something, and it's moving to someone else. And that is very visible in this thing. You can see over time how it has moved around. And actually, you can also get a version of BGPlay on the RIS stats.right as well. Then there are lots of other multiple network looking glasses. These are all tools for network operators. There is the packet clearinghouse route collector AS3856 at a large number of exchange points around the world. If you want to know what routes are easily available at any exchange point, these are a good source. Then most internet exchange points also have their own looking glasses, like the Hong Kong Internet Exchange links, like old stuff. There's a list of all these route servers available at traceroute.org, but you know, a lot of that info in traceroute.org is kind of outdated now. It's not updated, but it's still worth it when you don't have anything to look at. And the key thing about this is a lot of people don't realize, but if you need historical data for research or for planning, most of these people will give it to you. You might have to sign some NDA or non-commercial use, whatever it is, but you know, it's very easy to get data from any one of these if you ask them for it. There are more resources for network engineers. There is the Hurricane Electric BGP Toolkit, which you can go to bgp.he.net. This uses BGP, Hurricane Electric internal BGP data, other data from route views, and a bunch of other sources. The good thing about the Hurricane Electric BGP Toolkit is the packaging. You can get all that info elsewhere, but you need to spend a lot of time finding that info, right? So the Hurricane, I'll show the snapshot next, but you know, in one page, they provided you the whole picture and multiple things with it. And that is really useful when you're trying to quickly gain information from a bunch of sources. Then there is peering DB, about which we'll talk tomorrow, but it's also a pretty essential tool for any network these days that does peering and, you know, interconnect. This is a snapshot from the HE BGP website, and this snapshot is for AS15802. And it'll show you how many prefixes they originate, how many prefixes announced. And, you know, this is a slightly bad example, but that difference there, how many prefixes a carrier is originating and how many prefixes they are actually announcing, is a good measurement of how big a transit carrier they are. You know, carriers that are primarily transit oriented have a lot more prefixes being announced. They originate very, very few prefixes, right? If you are an eyeball network, you are originating a large volume of prefixes and announcing the similar volume of prefix, right? So it's a good way to know if somebody comes to you and say, hey, I'm a transit provider, to go and look at it and immediately know. It also shows you how well they are connected. BGP peers, 90 of them, and how much IPv6 they do, and all of that kind of things, very easily. And then whom their general upstream providers are, who they connect to. And up there you can go and look at there's a bunch of other really interesting data. As I said, you can find this info from CIDR report. You can go and generate this from route views. But this is the packaging, one-stop shop, and that is really useful. This is the peering DB entry, and we'll talk about it tomorrow because we're running out of time. So I talked about a couple of tools. How do you use it? That's what people ask me about. Right? That's the most important part of it. So, for example, we have a routing trouble. Somebody tells me, hey, XYZ is not working. Can you take a look? What do I do? Take the IP address, go to the Hurricane website, put it in there, see, click. You'll get a whole list of where that ASN is, who their upstream is. You have an immediate idea of the general topology surrounding that particular ASN and network, right? And then you can go and take that particular ASN, plug it into BGPlay, see if there has been a topology change, right? A lot of times escalations happen because the NOC doesn't realize there has been a fiber cut somewhere. We had a major fiber cut in Asia last week. APCN2 is down, like 2 multiple dual cuts. And that is reflected elsewhere. But there is enough density that it didn't really take things out. But sometimes it can happen, 2 fiber cuts in 2 different parts of the network, and then you'll see a huge amount of shift happening, and that creates a lot of problem. So you can go and look at BGPlay and see, hey, what happened? Is this prefix changed? I was seeing this through Europe, now I'm seeing this through Asia. Obviously, there's going to be latency issues, right? Then you can cross-verify your assumption or your data through ARC or CIDR report. And then, of course, if you have RIPE atlas points, you can go and look at a RIPE atlas in that network and see. As network operators, feedback or complaints that you get from end users don't really have a lot of info, right? They just say internet is not working, fix it. So how do you go and get real data out there? So that's where the RIPE atlas is useful, because you can go and run your one-off measurement saying, okay, let's go to this particular RIPE atlas here and see how it looks like. I don't trust the report that's coming out from the user, because sometimes they're using, some weird thing going on. The other thing is the routing trouble that you may have actually might originate in your network. And that's where having access to route views is really good. Because sometimes, there might be a fault or something is leaking and things like that happening. And, it's useful to have a view of your own network as seen from outside. Maybe something got disconnected. Maybe somebody fat-fingered something and you stopped announcing the route, for example. Or you are leaking something, like a more specific leak is very common because you have it internally and you started leaking it to someone by mistake, and that can create problem. The other one was network expansion. So you can use the same data, same set of tools when you're trying to expand. How do I do it? I go and look at CADA ARC. I look at all the hubs in the region, and obviously you try to go there first. And then, you go identify the hub through the CADA ARC data, then go through peering DB, see who is available in those cities, at which data center, right? How big the internet exchange there is. Then you can go and look at one of the many internet exchanges, HE or PCH, looking glass, see who is there, who peers easily, and then basically all these tools together will help you narrow down where you really want to go. So if you have a specific requirement to go to a certain network, you can go use these tools and say, okay, if I go to Hong Kong, I'll get to see most of Asia, including Japan. If I go to Singapore, I don't really see the Japanese guys there, right? So you can use these tools to go and find that kind of info and make up your plans. Now, my last but one slide. Obviously, a lot of people are going to ask, so how do I get hold of all these probes? The CADA ARC stuff is really small. It's the size of, multiple, like something like this small. But they like to have it on a public IP and IPv6. So if you are interested, talk to me. I'll introduce you to the people at CADA, and you deal with them directly. RIPE Atlas is available on request on the website, and of course, you talk to the RIPE staff outside there. Route views is at IXPs only, so if you run an IXP, it's good to host them. But route views is also something that you can peer over the internet, eBGP multi-hop. So you can send a request, start BGP peering. They will not announce you anything. My last slide. They will not announce you anything, but you can announce your own routes to them, right? And a lot of people say, why should I announce my routes to them? If you're on the internet, if you don't announce anything, nobody's going to get to you, right? There's still ways of finding out what you're announcing to other people, right? So by not peering, you don't really hide anything or protect anything. So coming to the last slide, conclusion, it's good stuff. A lot of people think measurements are for academics only, but measurements are equally important for network operators. And by being part of that ecosystem, it helps us to actually do a lot of troubleshooting. And the other part, that wearing a bit of an academic hat, is the more data we contribute to these things, the better it gets, because that's where all the research people get their data. And the richer the density of data in these collection systems, the better future internet is going to be for everyone. Questions?
Thank you, Garab. Questions?
Yeah, sorry, I had to run through a bit of this.
Yeah.
So.
No, it's Marco Rapensi. Actually, not for you, but the people in the room that have network operating centers. How many of you have alternative connectivity in your NOC? Because as Garab showed, you get a lot of useful data from external sources. And as a suggestion, keep external data in your NOC so you can access these sites when things go wrong. That's my experience, at least for running NOCs for 15 years.
Christian, RIPE NCC. What I was missing at the slide before, when you listed all the tools that you could use if you have routing problems or if you want to investigate on that, it was RIPE-Stat. And RIPE-Stat is basically our interface to a lot of data sets. So it's not only limited to routing information, also registration information. And just to clear that up, RIPE Atlas is a collection network. So on RIPE-Stat, you can access the data, whereas on RIPE Atlas, you are going to create the measurements, which you then can analyze.
Yeah, I had a whole couple of slides on the RIPE-Stat and RIPE Atlas that I removed because they're going to talk about it tomorrow. But it's pretty important part of it as well.
Other questions?
So how many people here actually host a RIPE Atlas? How many of you want to actually host it now that you know about it? Oh, thank you. How many of you are interested in the CADA ARC stuff? That's a bit more complex. Yeah. Okay, so please talk to me, and I'll help you get them to you, and they'll send it to you. And yes, Elvis, you have something?
Hi, Elvis before escrow. Does the CADA prefer or only works with an IPv4 public address?
It will work behind a NAT, but as I said, they prefer it to be on a public IP, an IPv6.
Yeah, I was wondering whether, for example, I use my RIPE Atlas probe at home.
Yeah, so
where it is behind my own router, but then.
Yeah, so I've talked about this with CADA, and their scale of things is much smaller than Atlas. I mean, Atlas is like thousands of them, whereas there is only hundreds of the ARC, and they want to use a public source address to do the trace route because, for data validity and trying to keep the data set safe. They've been experimenting by putting a few CADA ARCs inside their staff engineers' houses, but I don't think they want to encourage that to be done widely. They want it on the public IPv4 v6 for that reason. So and there are other people, and when it comes to measurement, the TTM is good because it has a time source, right? And that's what we really liked about it. Whereas CADA guys, they've decided that if they insist on a hardware clock with a dedicated time source, they are going to have issues with it, right? Or they can't get it as many as possible. So, but that is also a reason why they don't want a VM, because in VM there is no way they can have a time source. At least with the Raspberry Pi, they control the time source, and it's the same across the entire measurement network. So, but this is something for people who do measurements, not for network operators. No, host it, use the data, and you'll find it useful.
Thank you, Gaurav. Question. You showed us how networks are connected to each other. In Saudi Arabia, we are starting a project. We want to have a better understanding of how service providers, enterprises are connected to each other within the country. I'm not interested in anything outside the borders, but internal connectivity and building maps for that. How do you recommend we start something like this? What will be the sources available where we can start a project like this?
I think for something like that, the Atlas is probably a right tool, because this is a complex problem, because not all operators want to share the data. But the routing tables will never lie, and all network engineers want efficient paths to everything. So having something like a RIPE Atlas inside each of these networks, you can run traces between just those blocks of things, and then you can get a pretty good understanding of who is routing where. When I do that in Australia and New Zealand now and then, is to make sure that the RIPE Atlas probes I have, or I know friends have in New Zealand, are not all inside the same ISP. So you put it inside different ISP, and if there is a problem I see in Australia or New Zealand, I go and start doing probe traces from one to the other. Because in that case, I don't have to go and engage a lot of people. I know immediately if it's a temporary problem or a more permanent problem. The other way would be, to set up a measurement box at CITC and have, RIPE Atlas do traces to them, see how they get to you. But that will give you connectivity just to yourself, but not between what operators are doing. Yeah. So, there are multiple ways, but having done network operations, sometimes the operators won't tell you unless you go regulatory-wise and say you are going to tell me this. But to automate all of this, I think at least off the head, I can say the Atlas is a good thing, because that can go to end user houses. It can be kept somewhere, and they'll just run traces, and you don't really have to worry about it as long as you have Atlas inside each of these networks. Right. The other thing that I sometimes see as network operators is a lot of times when you email the counterpart NOC and say, hey, can you see what the problem is? They do a trace route from the NOC. Right? So you don't get an idea of what is wrong with some DSLAM somewhere out in the edge. And that's where the Atlas is useful again, because those things tend to be at houses more than at NOCs. And so you run a trace. So there are multiple ways of doing this. But I think Atlas is a good way of doing it. I think so. Yeah. But there is also other tools you can look like. You can use the Renesas tool, or you can use Looking Glass tools to see how dense the connectivity is between carriers. It's very easy to determine who is connected to whom by looking at the global routing table. Most often you can find the data if you really look for it. If they are connected to each other, there's some ways of you'll find it out, leak it out, right? And yeah, Renesas might be able to tell you as well. Not always, but you can get pretty close with the data.
Okay. We can always carry on the discussion at lunch. So where is lunch?
Straight down the hall, that way.
Okay. Okay. Thank you, Garab.
Thank you very much.
Thank you.
So I'm going to make an announcement that I was hoping somebody would do. We are having the MENOG peering forum tomorrow, and we'll run a bunch of peering personnels in which we'll ask you to come up and tell about your network in a single page. I have a template for it. If you go to the MENOG website, go to Agenda, go to the peering forum. There is a template for the MENOG peering forum peering personnel. And if you're interested in doing that, please use that template. The template already has an email address in it that you can send your peering personnel to. And I'll explain this tomorrow morning, but just giving you a heads up, the template is on the agenda page. Go and look for the peering personnel template and fill it out and send it over. Paul. Thank you.
Yeah, thanks, Garab. And before we just run to lunch, I just wanted to say thanks very much, Garab. We do have that peering forum tomorrow here, and some of you may be really well versed on this, some of you not. I urge you all really to come to this, because this happens in the rest of the world, and it's not so prominent here within the Middle East area. And okay, we have to start somewhere. So I think that if people come and understand what this is all about and follow this tomorrow, I think you'll be doing all of yourselves a service, and definitely for the Middle East networking community. So please do consider that. Thank you. Okay, let's go to lunch, please.